Okay, boys and girls, we're going to work on equivalent fractions, and if we look at the word equivalent, we know that means equal. So I'm just going to have you think about if we had a fraction of 1/2, what would be equal to 1/2? So just talk with your partner, and what do you think is the same thing as 1/2? All right. Now that you're back, I have a pizza here that is one whole pizza, but I cut it into thirds. I get to have 1/3 of that pizza, but I can't eat all 1/3 of this big pizza, so I want to cut it into another part so that I can eat it. Now, in order for anything with fractions has to be equal. So whatever I do, it has to be equal. Well, I see I have 1, 2, 3, 4, 5, 6, 7, 8 parts. Well, I can cut it in half here, and now I have 2 parts out of how many equal parts? Well, if I look, I have 1, 2, but that's not equal. It has to be equal. So I have 1, 2, 3, 4, 5, 6. I have 6 equal parts. So I have 2 out of 6 equal parts here. And if you need to see those equal parts, I can do that for you. They have to be equal. I couldn't just say here. Here, those are all equal. And that's how I got my 6. If you notice, they're equal parts. I couldn't just do, some people would have said, well, why didn't you cut it like this? Whoops, sorry. Cut it right here. Well, because that's not an equal part. This isn't the same. It's not the same. It has to be equal. So it equals 2, 2, 6. Well, that's still a lot of pizza for me to eat, so I want to cut it again. So I'm going to cut them into more equal parts. How many equal parts do I have? 1, 2, 3, 4. Well, I have 4 equal parts out of how many? I get 4 out of how many? Now remember, we want to have them equal again. So if I look, oops, gotta make my square. 1, 2, 3, no. Look, they're equal now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is 4 12s. And they're really all equal, and they're equivalent to what? 1/3. I still have 1/3 of it, but I just broke them into more parts. So that's one way of showing equivalent fractions. Another way to look at equivalent fractions is with the fraction sticks. And if I had 1/3 and we said that 2 fourths were or 2 sixths were the same. I'm trying to find my 6 right here. Here is 2 sixths. Yep, they're equal. They're the same. I could put them on top of each other, and they would be exactly the same. We said 4 12ths was the same. And if I lay 4 12ths out, they're exactly the same. So take a second and talk to your partner about, what do you notice when I went from 1/3 to 2 sixths to 4 12ths? Is there anything you noticed? So now that you talked to your partner, let's grab another one, and let's grab a 4th. And what would be equivalent to a 4th? Well, can it be a 5th? How about a 6th? No, I can't get 2 of those. How about an 8th? Let's see. Yep, 2/8 is equivalent to 1/4. How about a 12th? Is there a 12th? How many 12ths? Yep, 3/12. So how am I getting those? So I want you to take some time, shut the tape off, and I want you to experiment with the fraction bars and just start looking at the patterns of what they're doing every time. You know, look at this and then look at this. How is that equivalent? How are these two equivalent? Is there anything going on between them that you can notice? All right. So now that you've played around and hopefully you figured out that because with fractions, whatever you do to the numerator, you have to do to the denominator. So if I look at that 1/4, how did I get to 3/12? How did I get there? What did I have to do to get? Well, I know I went from 1 to 3. I took it times 3. 1 times 3 is 3. Well, what I did to my numerator, I have to do to my denominator. So 4 times 3 equals 12. So did that work with 2/8? I took it in both times. 1 times 2 got me to 2. 4 times 2 got me to 8. So whatever I do to my numerator, I have to do to my denominator. So if I want mine to get broken into more pieces, I would multiply it. Well, what happens if I get, let's say, 6/12, and I want to know, I want to make them into bigger pieces, and I know to get bigger pieces, my number has to get smaller on the denominator. So what would be the inverse of multiplying? It would be dividing. And the same rule applies. What I do to the top, I got to do to the bottom. So what can I divide 6 equally into? Well, I can divide it by 6. So 6 divided by 6 is 1. 12 divided by 6 is 2. So 1/2 is equivalent or equal to 6/12. Could have I done another number? I could have divided them both by 3 equally, sorry. So 6 divided by 3 is 2. 12 divided by 3 is 4. 2/4 is equivalent to 6/12. Now remember, you have to be able to do them to both, because I could take the number, let's just pick any number, 18/24. Okay? Well, let's say, I can divide that 18 by 9. So that would be 2. But can I divide 24 equally by 9? No, I can't. So there isn't an equivalent fraction to 18/24 if you divide them both by 9. Now they're even numbers. I could find the equivalent fraction of, I have to find a common factor, a common denominator that would common factor that would go into both of those, a common multiple. So I could do a 2 because I would get 9/12. And I would have it. Could I do 3? I think I could, because 18 divided by 3 is 6. 24 divided by 3 is 8. 6/8 is equivalent to 18/24. So I want you to play a little game and write down your answers as you're going. I want you to shake the 2 red dice, and the smaller number is always your numerator. The bigger number is your denominator. I have 1/5. I want to find an equivalent fraction to that, so I'm going to shake the green dice and take them both times 1, but that's going to give me the same thing, times 4. So I have, what I do to the numerator, I have to do to the denominator. So 4 times 1 is 4. 4 times 20 is, or 4 times 5 is 20. 4/20 is the same or equal to 1/5. They're equivalent. So I'd like you to play that game for a little bit, and then I would like to have you come over and explain what you're doing to me, and to see if we are ready to move on.